Hey, Dr. Clark coming at you with the Differential Equations Check Your Understanding video, section 4.4. This section is all about solving non-homogeneous linear differential equations. So you can see that we have a linear differential equation, and you can see that it's not set equal to 0, so we got a right-hand side, making it non-homogeneous. So they want us to find the general solution and then solve that initial value problem. So let's do that together. So first we're going to find the homogeneous solution, so YH, and that means so let me just say it. So we're going to solve the homogeneous problem, and the homogeneous problem is y double prime plus 4y set equal to 0. So that's that homogeneous differential equation. We write down the characteristic equation, which in this case is s squared plus 4 equals 0. We can see that that's not going to factor. If you use the quadratic formula, you're going to see that the roots are s equals plus or minus 2i. Or if you prefer, you can think of that as 0 plus or minus 2i. So my solution, my homogeneous solution, is going to be c1 e to the 0t cosine of 2t and c2 e to the 0t sine of 2t, right? That's when you have complex roots, you get an e to the t cosine of t and an e to the t sine of t. Now, most people would say, well, e to the 0t is just 1, so you could just cut to the chase and write c1 cosine of 2t plus c2 sine of 2t. Or you might have even just looked right here and said, oh, that's sine and cosine, sine of 2t. You know, once you get good, you'll start jumping right to seeing those solutions very quickly. So now I've got myself set up with a homogeneous problem. So that's part 1. Part 2, I'm going to solve the non-homogeneous problem. And I just need any solution. Any particular solution will do. And the non-homogeneous problem is y double prime plus 4y equals what? 8t squared plus 12. And so the way we do this is we guess. So I pick my particular solution. So I know that when I take functions and their derivatives, if they're going to end up being t squared functions, I'll probably start with a t squared function. And so let me try at squared plus bt plus c. Let me take the first derivative of that. And that would give me 2at plus b. And let me take the second derivative of that. That would give me 2a. And if I write down the differential equation with yp plugged in, the second derivative is 2a. And then I need 4y. And y is yp in this case. So that's at squared plus bt plus c. And that is supposed to equal 8t squared plus 12. And what can we figure out here? Well, I'm gonna take each power of t separately. So the first thing, I'm gonna have 4at squared on the left-hand side. And I'm going to have 8t squared on the right-hand side. So those are all the t squared terms. And if you look at that, that's going to very quickly tell you that a has to be equal to 2. So now I know what a is. Then I'm going to look at the linear terms. So 4bt has to equal 0. So that must tell me that b must be 0. And then I'm going to take the constant terms. So 2a plus 4c, that has to equal 12. Now I already know that a is 2. So 4 plus 4c has to equal 12. So c must equal 2 as well, so that 4 plus 8 equals 12. So a is 2, and c is 2, and b is 0. So that tells me that my particular solution must be 2t squared plus 2. And it should be the case that if I take the second derivative and add it to 4 times the function, I get 8t squared plus 12. So there's my particular solution. And that is number A. It's almost number A. I need to write down the general solution. So step 3, what is the general solution? Well, the general solution is the homogeneous solution, C1 cosine of 2t plus C2 sine of 2t added to the particular solution 2t squared plus 2. So that's part A. Write down the general solution. Part B is solve the initial value problem, y of 0 equals 5, y prime of 0 equals 10. So y of 0 equals 5, y prime of 0 equals 10. And if I take my general solution and plug in 0, what will I get? Y of 0 will be, cosine of 0 is 1, so there's C1. Sine of 0 is 0, so that's plus 0. 2 times 0 is 0, so C1 plus 2 has to equal 5. So that tells me that C1 must be equal to 3. And then if I look at the derivative and evaluate that at 0, so what's y prime of 0? Well, the derivative of cosine will be sine, so when you plug in 0, you'll get 0 there. The derivative of sine will be cosine, so if I plug in 0, I'll get 1. So it's going to be 2c2. The derivative of 2t squared here will be 4t, but when you plug in 0, you get 0, and the derivative of 2 will be 0. So I think the only term that survives is this 2c2 cosine of 2t, basically, and then when you plug in 0, cosine of 2t becomes just 1. So basically 2c2 has to equal 10, and so that tells you that c2 is 5. So now I've got c1 is 3 and c2 is 5, and I can write down my solution to the initial value problem. Y of t is 3 cosine of 2t plus 5 sine of 2t plus 2t squared plus 2. And that solves the initial value problem right there. All right, so hopefully you were able to solve that problem as well. Make some reflections over here. What did you understand? What was easy? What was hard? What do you maybe want to study for later? And check down here. Give yourself a grade, and we will see you next time.